We are starting new chapter beta and gamma special functions. So firstly, two formulas you have to remember. One is beta, one is gamma. 0 to 1 x power n minus 1, 1 minus x power n minus 1 dx. So here it can be x or y or t or anything. So it's a variable. It doesn't make any difference. You should remember the limits. So these are x limits. X is equal to 0 to 1. While coming to gamma, here also x is variable and exponent term should be must. So the limits are 0 to infinity. So limits are very important. E power minus x, x power n minus 1 dx. Okay. And proofs of properties and forms we'll see later if we have time, because now we have to concentrate more on sums and PYQs. So if you're done, we'll go to PYQs. So beta of m comma n, we can write it reverse also. This is called symmetry property. Next, we can write beta of m comma n as m plus 1 comma n, then m comma n plus 1. This is very important. We'll be using in sums. Beta in terms of trigonometry. So here into 2, 0 to pi by 2 are limits, and here m minus 1, no, here 2m minus 1. So 2, just remember, you'll get everywhere 2, pi by 2, 2, 2m minus 1. Okay, this is very important. Next, these forms, these are sums like you have to prove. If you want, you can remember, or else not needed. And this is very important. Relation between beta and gamma. Beta of m comma n is gamma m by m plus n. And next, coming to gamma. Gamma 0 is undefined, gamma 1 is 1, and gamma 0, gamma minus 1, minus 2, all these are undefined. Next, gamma n plus 1, very important formula, n gamma n. See, the formula, what you should learn from this means, if I have gamma 3, I can write it as 2 gamma 2. That's what you have to interpret, okay? Gamma 3 can be written as 2 gamma 2. In the same way, in formulas, if I want gamma of n, how can I write? See, n plus 1 I reduced and I wrote it as n and n, no? So if I want to write gamma n this side, then I can write it as n minus 1 gamma n minus 1. So I decreased 1. Here also I decreased 1 and wrote n and n. Here I decreased 1 and I wrote n minus 1 gamma n minus 1. That's what you have to interpret. Next, this is other form of writing gamma, where z is an integer. So if you want to, here it is e power minus x. If you want something like e power minus zx, then the answer will be gamma n by z power n. Then you can write this form. These are all like proofs you need to study. Now first go to sums. So next very important thing is how to solve gamma problems. This, see, I'll give you some like tricks. So firstly, when it's positive and when numerator is less than denominator, like 1 by 3, 2 by 3, these we will leave. We cannot further simplify, okay? But if they come in group, okay, if they come together, then you have to just check for this formula. If they are okay, see, gamma n and gamma 1 minus n is pi by sine n pi. How do you check? So 1 by 3 and 2 by 3 are there, no? So let me take n as 1 by 3. Okay, so then you have to do in rough 1 minus 1 by 3, which is 3 minus 1, 2 by 3. So they are satisfying. So here my n is 1 by 3. So I will write this as pi by sine 1 by 3 into pi by 3. So like this we will solve. So this is the first case where it's positive and numerator is less than denominator. Okay. Next, second case. So next sums are, it is positive and numerator is greater than denominator. How to solve these kind of sums? So here we'll be using this formula, which came from this only. I told you, no, n plus 1, I wrote n comma n, and if I reduced 1, I will reduce here also 1. Okay, so from this formula only I wrote this formula. So now I'll be using this formula. So how will I write this? Gamma of 5 by 3, I'll write 5 by 3 minus 1 into gamma of 5 by 3 minus 1, which is 2 by 3 into 2 by 3 gamma 2 by 3. Can I solve gamma 2 by 3? No, because numerator is small. I already told you, like these things we cannot solve. So this is my final answer. And the trick I want to tell you, if you want, you can remember this formula, no problem in it. A small trick that I observed is, if something like this is there, 11 by 2, and you want to do it very fast in your exam, then you'll write like this. 11 minus 2 is 9. Okay, write 9 by 2. Again do it. 9 minus 2, 7. Again 5 by 2. Again 3 by 2. Again 1 by 2. Finally you should write gamma 1 by 2. Whatever finally you got, you should write it. And because I know gamma 1 by 2 value, which is very important result, you have to remember, root pi. So I'll write here root pi. And I'll solve it, will be completed. Okay. So what is this? Same, if you want, you can apply the same formula, n minus 1, gamma n minus 1. You can, finally you will get like this only, 9 by 2, gamma 9 by 2 you will get. Again gamma 9 by 2 you will do. You'll get the same thing, but this is just like fast calculation. So when coming to negative, either it is denominator less or greater, there is only one formula we'll be using. See here, minus 2 by 3. I don't want to do minus again, minus 1. It will go infinity times, so I have to going backward, negativity backward. So I want something with plus 1 formula, so that I can get through this one. So I'll write gamma n is gamma n plus 1 by n. So if I do plus 1, it will reduce and I'll get the answer. Okay. So this formula we'll be using for these cases, and this formula we'll be using for negative numbers. Okay, let's see how. So this is my gamma n. So how do I write this now? Gamma n plus 1. That means minus 2 by 3 plus 1 by minus 2 by 3, which will be, put it reciprocally into, this is 1 by 3. Can I solve 1 by 3? No. This is my final answer. In the same way, I'll do minus 7 by 2 plus 1 by minus 7 by 2. And I'll be doing like this. See, I'll be getting finally answer, something like very big one. That is okay, you will do it. But I want to tell one trick here. Just like this. Here, because denominator is greater, here also denominator is greater, so trick is same. Here I did 11 minus 2, 9 by 2. Again minus I did 7. Again minus 2 I did 5. Here also I'll do same. But because here minus is there, so we'll do ulta everything. For example, I'll write minus 2 by 7 into, here I'll write minus 2 by 5, minus 2 by 3, minus 2 by 1. But finally I'll write gamma 1 by 2 only. This reverse only I'll write. And I'll get gamma 1 by 2 root pi. I'll write. But see, what is the difference means? Here I started from 9. But here I started from the same term itself. Here I did minus and then started my trick. Here in this trick, I started with the same term given in question. So if you feel it's easy just for checking or something, then if you want, you can follow this trick, or else you just follow the formulas. Don't follow my trick if you don't like it. Okay. Okay. So in the same way, gamma minus 1 by 2, we'll do using the formula. So which is gamma minus 1 by 2 plus 1 by minus 1 by 2. So which will be minus 2. 1 minus 1 by 2 will be gamma 1 by 2, which is root pi. So minus 2 root pi. Like this, for negative numbers we can get, and for positive numbers we can get, but only in cases like numerator is small we cannot get. But that also, if they are in combined form, then we can check for this formula. So this is what you should remember. I hope you got some clarity on solving these sums. So these all you get in the big questions, not now. So we're going to sums. Evaluate 0 to 1. See the limits of 0 to 1. As soon as I see it, I can understand this is beta. Okay. And see here, I want in x, not something x powers. So whatever is theta, that will put my y. So put what is that you don't like. I don't like this, so I'm putting it as y. Okay. And I don't want to be it in denominator, I want it to be in numerator. So I'll bring it. Okay, first let's do derivative. X is equal to y power 1 by 5. So dx will be 1 by 5 y power minus 4 by 5 into dy. Now I'll write this 0 to 1 x square, taking it up. This is power 1 by 2. So when it goes up, it will become, wait, minus 1 by 2. Okay, dx. So now this will be 0 to 1. What is my x? Y power 1 by 5. So y power 1 by 5 whole square. 1 minus x power 5 is y, no? Minus 1 by 2. So what is my dx? 1 by 5 y power minus 4 by 5 dy over. Now if you solve, you'll get your answer. So I'm taking constant outside. I'll take minus 1 by 5 and only 1 by 5. Here y power 2 by 5 and here minus 4 by 5. So I'll get y power minus 2 by 5 dy. Now compare this with your formula. Here x is there, here y is there. I told you, these are variables, both are same. So what is my m minus 1? Minus 2 by 5. What is my n minus 1? Minus 1 by 2. So therefore m minus 1 is minus 2 by 5. N minus 1 is minus 1 by 2. So my m is 3 by 5. N will be 1 by 2. Therefore 0 to 1, x square by root 1 minus x power 5 dx is 1 by 5 beta of m comma n. What is my m? 3 by 5. What is my n? 1 by 2. Okay, so it's done. So this I wrote it, beta of something. These are the limits 0 to 1. Okay, the question is evaluate in terms of beta function. So I'm leaving my answer here. Okay, see another question, same form. Put x square is equal to y. Okay, then x is equal to y power 1 by 2. Dx will be 1 by 2 y power minus 1 by 2 dy. So I can write this as 0 to 1. X is my y power 1 by 2 and x square is my y. What is my dx? I'll write directly outside 1 by 2 y power minus 1 by 2. So what I'll get? 1 by 2 gamma 0, sorry, limit integral. This will be 1 by 2 minus 1 by 2, it will be 0. Okay, now if I compare with my formula, I'll get m minus 1 as 0. M minus 1 as 0, so m will be 1, and n minus 1 as minus 1 by 2, so n will be 1 by 2. So this is answer will be 1 by 2 beta of 1 comma 1 by 2. Okay, express in form of beta, so I'm leaving the answer here. See, next question I have this. As soon as I see limits, I can understand this is gamma question. And in gamma, see, I want e power minus x. But here what is there? Minus 4x is there. So what I'll put, what is theta? 4x is theta. So I'll put 4x is y. X is y by 4. Then I'll get dx dy by 4. Limits will be not changing. Check, limit won't change. Next, so we'll write 0 to infinity e power minus y. X will become y by 4 power 5 by 2. Dx will become dy by 4. I'll bring all constants outside. So I'll get 1 by 4 power 5 by 2 and this one another 4. Next 0 to infinity e power minus y power 5 by 2 dy. So what this is my answer. Here my n minus 1 is 5 by 2. So n here is 7 by 2, right? So I can write it as 1 by 4 means 2 square. So can cancel 2 power 5, 2 square. So 1 by 2 power 7 gamma 7 by 2. And I told you how to solve gamma 7 by 2, which is 1 by 2 power 7. Gamma 7 by 2 will be 5 by 2 into 3 by 2 into 1 by 2 into gamma 1 by 2, which is root pi. So if you solve this, you will be getting answer 15 by 1024 root pi. Okay. So this is gamma question. Next we'll see another some questions. So this is 0 to infinity e power minus x square dx. So as soon as I see limits, I can understand it is gamma function. What I have in my formula, I have e power minus x, and here I have x square. So this is only data, so I'll put x square as some y. So x will be y power 1 by 2, dx will be 1 by 2 y power minus, okay, minus 1 by 2 dy, or I can write it as root y. It goes down, so 1 by 2 root y dy. Okay, now I'll put in this in here. So I'll be getting 0 to infinity e power minus x square dx as limits 3. Will they change? No, same. 0 to infinity e power minus y by root y. I'm writing 1 by 2 directly outside dy, which is 0 to infinity e power minus 5 y power minus 1 by 2 dy. So here n minus 1 is minus 1 by 2. So n is half. So I can write it as 1 by 2 gamma 1 by 2. This is my gamma formula, which is, this is root pi. So I'll write it as root pi by 2. And this is very important result. Directly we'll be using wherever we see it before chapters also. So let's write it here. Integral 0 to infinity e power minus x square dx is root pi by 2. Gamma 1 by 2 is root pi. Don't get confused. Very important results. This will be using in almost all chapters. Integration chapters. To see next question. Here I'll put x cube as my y. Okay, then x will be y power 1 by 3. Then dx will be 1 by 3. Y power 1 by 3 minus 1. It will be 2 by 3 minus 2 by 3 dy. So now I'll write it as 0 to 1 x power, so y power 5 by 3, 1 minus y power 10, 1 by 3 outside, y power minus 2 by 3 dy. 5 by 3 minus 2 by 3 is 1, so 1 by 3 y power 1, 1 minus y power 10 dy. Therefore here m minus 1 is 1, so m is 2, n minus 1 is 10, so n is 11. So this is 1 by 3 beta of 2 comma 11. See, if it's mentioned in question. Okay, beta of 2 comma 11, so gamma 2 gamma 11 by gamma 13. So gamma 2 is 1 factorial, so it's 1 only. Gamma 11 is 10 factorial, and down 13, gamma 13 means 12 factorial. So 12 into 11 into 10 factorial. So it will be 1 by 3, it will be 1 by 396. This is very important question. Here, through limits, you can see this gamma function. But as I told, for gamma function, we need exponentum. But we cannot say exponentum. So we should create one exponent. As we know, e power log a is a. So anytime you have e power log a, so natural logarithm, so base is e. Whenever you see, you can directly write the a. So now we'll apply this. So I want to write 3 as like this. So I'll write e power log 3. Base is e. So if you write it down, no problem. Power minus 4 x square dx. So now what I can do, 0 to infinity e power, we can multiply them, so it will become minus 4x square log 3 dx. So now if you see, we got some exponent now. So I'll put substitution now. So the trick not, it's, you have to remember that put t is equal to root of this. Normally what we put, just this small thing we put. Now what, to get easy calculation, we need to take like this. Okay, now t will be 2x root log 3. So from here I'll get my x as 2 by t by 2 root log 3. So dx will be dt by 2 root log 3. 2 root log 3 is constant, so we are not derivating it. Okay. So now I'll put substitution here. It will become e power t square minus t square dt by 2 root log 3. I'll directly write outside 1 by 2 root log 3. Okay, 1 by 2 root log 3. What is this formula? Root pi by 2 as already a very important result. So your answer is completed. But if it is for 7 marks, then you will again have to take t square is equal to u and you will be proceeding. Before we already did, when it's y square, we already proved the same result. In the same way, we will complete this if it's for 7 marks. So see, evaluate this. So by seeing the limits, where it is beta function. But for beta function, what is the formula? 0 to 1. 1 minus x power m minus 1, 1 minus x power n minus 1. So I want only 1, nothing else. But I have here 9. And I also need x term, but I don't have. So I can write x power 0. Okay. I'll create 1. How? I'll take 9 common. So it will become x power 0. 1 minus x by 3 whole square I can write. 9. I'm writing x by 3 whole square. How I'll take 9 common? 9 power minus 1 by 2. Okay. Dx. So now it is in this form. Now which is theta? I have x by 3. I want only x. So I'll put theta as my y is equal to y. So what will be my x? This will be y power 1 by 2 into 3. Okay. So dx will be 3 into 3 by 2 y power minus 1 by 2 dy. So now lower limits will change now. See, putting x is 0, y will be also be 0. Putting upper limit x is 3, this will become, y will become, this into 3 will become by 3, 1, so it will become root 1, so it will become 1. So lower limit will be 0, upper limit will be 1. So my limits are going to be 0 to 1. Next, x, this is okay, 1 and directly write x power 0. Next, or else I can write y power 0 also. 1 minus y dy. Putting constant outside 3 by 2. And y power minus 1 by 2 this. I'll write here y power minus 1 by 2. Okay. This is power minus 1 by 2. I forgot to write here. Minus 1 by 2. So my m minus 1 will be minus 1 by 2. n minus 1 will be minus 1 by 2. So m comma n will be 1 by 2. So I can write it as 3 by 2 beta of 1 by 2 comma 1 by 2, which can be written as 3 by 2. Gamma 1 by 2 is root pi. Again gamma 1 by 2 is root pi. Gamma n plus n, which is 1, so it will be 1 only. So also here 9 power minus 1 by 2 means 1 by root 9, so I will be getting 1 by 3. So it will be 1 by 2 pi, so it will be pi by 2 is your answer. And if it is like this, what will you do? You will take cos theta power 0. Okay, and then this will be your 2m minus 1. This will be your 2n minus 1. You will get m comma n values. And because you multiply 2, you should divide 1 by 2. It will go that side. It will become 1 by 2 and beta of 4 comma 1 by 2, which is gamma 4. Gamma 1 by 2 is root pi. Gamma 9 by 2. And if you do calculation, you will get just 16 by 35. If root cot theta is there, it is cos theta by sin theta root. So that means I can write it as cos theta power 1 by 2, sin theta power minus 1 by 2. Okay. Then this will be using the formula. I'll get m 1 by 4 and 3 by 4. Then 2 will go that side. 1 by 2 beta of 1 by 4 comma 3 by 4. 1 by 4 comma 3 by 4 means I'll get gamma n gamma 1 minus n formula. I can apply that. And I'll get my answer as 4, which is 1 by root 2. So I'll get pi by root. Times error function may be asked for 2 marks. So let's see. Error function means limits are from 0 to x. Error function of x. 2 by root 1 integral e power minus e square dt. So complementary error function is only limits change. That is x to infinity. So error and error complementary will give plus if you do, you will get 1. So the limits are 0 to x, x to infinity, 0 to infinity. So you understand 0, infinity, x. 0 to x is error function, x to infinity is complementary error function. Combinedly, we get 1. To here and to here, both add, we'll get 0 to infinity, e power minus t square, then that will be 1. Why? Because I already told you this formula. 0 to infinity e power minus s square dx is root pi by 2. So if I get here root pi by 2, cancel and it will become 1. That's how we get. Okay, now error function of 0, that means 0 to 0 e power minus t square dt. It will be 0. Lower limit, upper limit is 0. Next, error function of infinity, 0 to infinity. This is the formula you already know, root pi by 2. Cancelling, we get 1. Okay, next, we'll see some questions. Show that error function, complementary error function is 1 minus. So you'll go with definition. So we know that 1 is equal to. So you should remember that 0 to x, error function of x to infinity, complementary error function, and 1 is 0 to infinity. Okay, so from then 0 to infinity you divide the limits 0 to x to infinity. So this will be your error function and this will be your error complementary. Then from here you will show. Very simple. Show that error function of minus x will be minus error function of x. Simply we'll put in place of t some minus y. Okay, then lower limit will be 0 to x, no? Then they will change to 0 to minus x. So then we can, from here we will come outside. So here limit is minus x. So if limit is x 0 to x, it is error function of x. If limit is 0 to minus x, it is error function of minus x. And we have minus here, so we can go this side and we can prove it easily. Next question, show that error function of minus x. So as we just saw, error function of minus x means limits are from 0 to minus x. And here limits are from 0 to x. So we'll take this minus. We'll put t is equal to minus sign only in this term. And this will already get changed as we saw before. So we'll get minus outside. So then this and this get cancelled. We'll get minus outside. Here I'll get minus dy. So this and this get cancelled. So it will be equal to 0. Okay.